In that video, I'm going to talk about the linear differential equations of higher order, higher degree. In the sense, I'm not talking about single order, single degree. So this is the higher order, higher degree. Maybe the degree is 1, you can see, but the order is not 1 actually, order is n. So, however, in that case, this is the format. This is the first format, and AI in the sense A0, A0, or whatever you are saying, A2, A1, everything, AN, everyone, a constant. Okay. So, however, now this is the other format of this kind of differential equation. Basically, we are saying that d wait d dx, that's this is I, and this is again I, this is equals to d. Okay, so you can understand, right? This is not d actually, this is d to the power I. Sorry, this is actually d to the power I. If I is 1, then this is d. If I is 0, then this is 1. Right, d to the power 0 is 1. So very nice. Now in that case, there are two possibilities. Maybe the equation is homogeneous, or maybe the equation is not homogeneous. So in that case, if the q, which is nothing but the function of independent variable, which is x here, if q is qx, actually qx is equals to 0, then it is homogeneous. Otherwise, if qx is not equals to 0, greater than or less than 0, in that case it is non-homogeneous. Now in that video I am going to talk about the homogeneous equation, but for information, if you want to calculate the solution of homogeneous equation, then you have to calculate what is that. This is CF. Why CF? And what is CF? CF is complementary function. Okay, CF is complementary function, and in case of non-homogeneous equation, you have to calculate the CF, and you have to also calculate the PI. PI in the sense particular integral. Some people are saying that PI is not, PI is a particular solution. Maybe yes, but according to PI, I is here, so not particular solution, it is particular integral. Particular solution is something different, which is applicable for partial differential equation. Classic solution is also applicable for partial differential equation. Some people are saying CF is classic solution. S is not there. There is F. This is complementary function. CS, or classic solution, is applicable for partial differential equation, PDE, of second order, third order, doesn't matter, whatever the order is. So in that case, point to be noted, if there are any kind of boundary condition or initial condition, I have told you, if boundary condition in the sense, if t, that means time, is not mentioned, then this is boundary condition. Like y0 in the sense where x is 0, then the value of y is, let's say, 1. Y0 is 1. Y2 in the sense where x is equals to 2, then the value of y is equals to, let's say, 10, just assume. Okay, and if there is kind of initial condition, then t will be mentioned. However, if there are boundary conditions, then use them at the final solution. Final solution in the sense after getting CF for homogeneous, or after getting PI plus CF in case of non-homogeneous equation. Now in that video, I'm going to solve this question, and I have sent you a not chat actually, actually kind of a list of formula for calculating the CF. So in that case, the first thing you have to do, you have to convert it into the second format, which is what? This is d square plus this is what? 12 into d plus this is 36 into 1 actually into y is equals to what? 0. Now you can see this is 0, that means what? This is a homogeneous equation, and these are the boundary condition. Because t is not mentioned here, so this is boundary condition. However, so how we can calculate the CF? We just have to solve this polynomial, which is nothing but looking like 12d plus 36 is equals to 0. We have to calculate this polynomial, the solution of this polynomial. Now it is very easy. It is nothing but what? It is nothing but d plus 6 whole square, right, is equals to 0. Now the value of d is what? Minus 6 and minus 6. As the roots are same, they are not distinct, so the value of ICF will be what? C1 plus C2 x into e to the power minus 6x. I have sent you the chart or the formulas, so you can easily calculate the CF using the formula. So I am not going to explain, right? Just remember the formula, okay? You don't need to know how we can get the formula at that moment, at least you don't need to know. So however, this is c1 plus c2x. Now the boundary conditions are given. So as I have told you that ycf is equals to y, so this is our solution, but you have to calculate the c1 and c2, which are nothing but the constants. What constants? Indefinite integral constants. Now I have to calculate the c1 and c2. How you can calculate? We can easily calculate it through this, to count boundary condition actually. So we have to put the boundary conditions here. Now y, the boundary condition is something like y is equals to 3 when x is equals to what? 0. So c1 plus c2 into 0 into e to the power 0, e to the power minus 6 into 0 actually, which is nothing but 0, right? So this will be c1 equals to 3. So our c1 is equals to 3. Very nice. Now we have to use the second condition, which is nothing but y dash x, right? Y dash x. We have to differentiate solution, the CF actually. So this will be y dash, let's say y dash is equals to what? E to the power minus 6x. I'm taking common actually, into minus 6 into c1 plus what? c2 x plus e to the minus 6x into 0 plus c2. UV rule actually, I am using the UV rule, right? So you can understand, right? Now we have to put the value of x and y, So the value of y is what? Minus 36, and value of x is what? You can see minus, not minus actually, 0. So this will be 1, this will be like minus 6 into c1, right? Because this will be 0, c2 into 0, which is 0, plus e to the power 0, which is again 1, and this will be like c2, right? Very nice. Now we can calculate c2 because we know the value of c1. So c2 is equals to what? Minus 36 plus 6 into 3. Nice. Now this is minus 36 plus 3 into 6, what is 18, so which is 18, and this will be like minus 18, right? So the value of c2 will be minus 18. The value of c2 will be what? Minus 18. Now we have to replace the value of c1 and c2 at the final solution. Wait, now this will be our final solution. Y is equals to what? c1 is 3 plus, not plus, minus 18, c2 is minus 18, right? Minus 18 into x whole to the power e to the power minus 6x. So this is our final solution for this question. Very nice. In the next video I will talk about some more examples so that you can easily understand. Goodbye.